All right, good afternoon, everyone. It is 12 or 1 p.m., so we will get rolling on this and have some more people filter in as they show up. Start off by saying good afternoon. Welcome to Dr. Stone Academy, last one of 2024 before the holiday season. I'd like to thank everyone for making time in their week for this. And without further ado, let's get started. So with me today, I have Vitaliy, who is another instrumental member of our technical support group, and I'll let him take it away from here.
Hey, thank you, Chris. Hello, everyone. Nice to see you today's webinar. Today we discuss 70 volt and 8 ohm system. So we'll discuss commercial audio system breakdown, difference between 70 volts and 8 ohms system, speaker impedance, and wiring and amperage. So let's start with residential audio system. As a baseline recreational audio systems. I skipped one slide. So as a baseline recreational audio system serve as quite a basic and streamlined setup. In home systems, speaker wire connects from each speaker back to the receiver. This system serve as stripped down and bare bone example of what sound system can be. Functional given the requirements, but the sky's is the limit with the commercial audio systems. In contrast, commercial audio systems are required to be much more powerful and scalable. With these systems, they aim to create a system optimal to the space. System functions can range from the simple chain that connects an amplifier to a speaker, and the first speaker connect to another speaker, and so on, all the way to the versatile paging, communication, and music system. This system also ideally modular and are set up in such a way that makes it easy to expand your system given the future requirements. Commercial audio systems are required to have greater functionality and configurability than the recreational ones, and an aspect of which including allowing multiple sources to the mixer amplifier system, which then travels through the system/speaker chain. When designing audio system, physical space or functionality determine what components will be used for the system, but they all can determine the style system itself. Often designing the audio system starts by asking how the sound will be distributed, analog, digital, mixed, etc. How large the facility or facilities, how will the system be used, paging, background music, etc. How loud do you need the system to be, ambient noise, machinery, so depends on the ambient noise you need to design system that be about the noise level. And how to aesthetics affect deliveries, like style, quantity, or of speakers. Speakers are either low Z or low Z, 8 ohms, or high Z, 100 volts, 70 volts, or 25 volts. Both have specific job to perform and do so effectively under different circumstances. Low impedance is a range of approximately from 2 to 16 ohms, often it's 8 ohms. Low impedance is ideal for high performance applications, high power speakers, and short cable runs. Low impedance sound system often you can find in the nightclubs, performance spaces, arenas, halls of worships, stadiums, and even in a car sound system. High impedance is typically an impedance of 25 volts, 70 volt, 100 volt. And ideally for longer cable runs with more speakers per line. Speakers are low powered with adjustable power tabs. It has high impedance outputs with the fewer amplifiers required. High impedance sound systems are ideal for public address, incorporate commercial, industrial, retail, or educational applications. Yeah. 70-volt systems are typically used for installations that require large amount of speakers to be installed. 70-volt transformer on each speaker allows you to have multiple lines of speakers connected to a single amplifier without the need to worry about the impedance issues as you will get with the 8-ohm system. So let's break down the 70-volt system. It is cost-effective alternative to more expensive 8-ohm systems. Simple wiring of loudspeakers can be easily expanded or downsized. Different areas can have different sound pressure levels achieved while using a single amplifier. Here we have a 70-volt wiring example. So here we're using a A2000 series mixer amplifier and a Beijing microphone connected to it. In this case, we have PM660U. You can use other microphones, even wireless microphones. As a background music source, you can use any source that has an unbalanced audio out. You can use our TOA DT940 tuner. And speaker output is a 70-volt connected with 2-wire conductor to, as in this case, to speaker lines. One of the speaker lines has a volume attenuator just for adjusting volume in the one particular space. Okay, let's go next. 70-volt system advantages. Long speaker lines are possible with appropriate wire gauge. All speakers are connected in parallel, no series wiring required. No need to maintain a specific impedance load to the amplifier, only any minimum load. Failure of the speaker or an open speaker transformer will not cause the system to fail. A selection of power tabs on each speaker allow for level adjustments in different areas to suit specific zone needs. Adding or removing speakers does not affect volume levels on existing speakers. Using higher voltage amplifier outputs allows the user smaller wire gauge. Simple wall attenuators can be used to adjust volumes in each zone. So let's break out 8-ohm systems. While providing the best fidelity and bass output can be more expensive system in the end. You may need to calculate aggregate impedance of the speakers per channel to make sure they fall within the range of the amplifier. This often creates a need to wire speakers in combination of series and parallel connections to fall within the appropriate range. This often creates the need to wire speakers in combination of series and parallel connection to fall within the appropriate range. Also, will be limited in the total number of speakers per channel. In different areas need to have different sound pressure levels. More than one amplifier will need to be used. Here we have 8-ohm wire example. In this case, we're using again the same A2000 series amplifier, and this amplifier has a 4-ohm outputs. So for this 4-ohm outputs connected 2 speakers in parallel. Each speaker has 8 ohms. So by using Ohm's law, 2 8-ohm speakers in parallel will give you 4 ohms. So it's matching the amplifier. If you need additional speakers to wire to the amplifier, you need to use the addition of series or parallel connection. Or if it's low, it becomes lower than 4 ohms, you need to use some kind of speaker selector or volume controls. 8-ohm advantages. So 8-ohm system can be play stereo. 70-volt system mono usually, but also can play stereo. 8 ohms home audio system have broad frequency response. Typically 70 volt system do not have as wide as a response due to using transformer. 8 ohm system has a greater sound quality and equipment and flexibility for speaker and amplifier options. So key takeaways. 70 volt system utilized for the large scale venues such as shopping malls require coverage through the facility. An 8 ohm system excels where the high-end performance is required in venues such as churches, amphitheaters, or even home car stereos. This system have greater control over speaker runs and more defined amplifier distribution, as previously mentioned. And we have summarized charts for 70 volt and 8 ohm systems. So 8 ohms, you can see the impedance range from starting from 2 ohms to 16 ohms. And for 70 volts, we have a 25 volt system, usually in the schools. Using 70 volt, it's mostly in the North American market, and 100 volts in European and other markets. And here we have Dr. Sound's note. So bit of the lengthier few slides here. Just want to add this note to complete clarity regarding the subject. To be completely accurate regarding the terminology surrounding today's webinar, 25 volt, 70 volt, and 100 volt terms are not measure of impedance, but rather description of what properly be called constant voltage amplifier output. In actuality, the true impedance, which is measured in ohms, not volts, can vary considerably in constant voltage systems, depending on the actual physics of the system components and the real amount of resistance introduced by them. The real physics involved can be fairly complicated to explain thoroughly, which is why the descriptions tend to get simplified to 8 ohms or 70 volts for ease of communication. The true measure of impedance still comes into play in constant voltage system designs, but it's expressed in terms of total speaker's load wattage versus rated amplifier output, which makes them easier to design. As the math involved is much simpler than low Z system, constant voltage speakers have onboard transformers that convert the applied power to appropriate for the driver. The installation troubleshooting stage it can be extremely important. Hence, the impedance meter should be used in constant voltage installations to ensure there are no faults. So one of the examples of impedance meter, you can use TOA ZM104. So it's a great tool for troubleshooting and measuring actual constant voltage impedance that of course is measured in ohms. So it should not be lower than nominal impedance of the amplifier. Impedance consideration. When low impedance speakers, typically 4 or to 8 ohms, will require an amplifier of the same output impedance. We emphasize the importance of this being matched, because if the two impedances are very close to the same value, and this is within the limits of available current from the amplifier power supply, then the system can deliver the expected power to the speaker without additional issues. A large mismatch here, speaker has too high impedance and the power capabilities of the speaker will not be realized, or worse, the speaker will draw too much current and the amplifier will burn out. So basically, when you do the power transfer calculation, you should match the impedance. If it's lower than that impedance of the amplifier, it can create issues like overheating and cause of damage of this amplifier or speakers. Therefore, we advise that it's important to keep these types of impedance requirements matched as close as possible. keep in mind that speaker impedance will vary over very large range from manufacturer's stated rating. As an example, 8 ohm speaker may actually vary from 4 to 40 ohms, depends on the frequency supplied to the speaker. Typically, a typical scenario here is providing connection between the microphone, analog phone system, or audio source device to the mixer input. Typically, these devices will have an output impedance of 600 ohms or so. Since we are not transferring power or large amount of current, we only need a signal voltage strength representative of the source to arrive at the input. Very little current is used. Inputs, because of the type of requirement, usually have a high impedance in the range of 10K ohms and draw very little current. So a good connection would be 600 ohm output to 10,000 ohms input. So next time you need to connect one of the devices to another, consider if the transferring power or a signal voltage. Consider the following. Impedance matching of inputs and outputs is only important when transferring power. When connection is transferring signal, we only need to make sure the device output impedance are significantly lower than inputs. So again, to reiterate, your source signal impedance should be lower, at least 10 times of your input. So in this case, you will have matched your input sources. For the output, because you're transmitting power, you should match the impedance of the amplifier output and your speaker line. All speakers are connected in parallel, no serious wiring required. No need to maintain a specific impedance load to the amplifier, only minimum load. Failure of the speaker or an open speaker transformer will not cause the system to fail. A selection of power taps on each speaker allows for level adjustment in different areas to specific zone needs. Also, the advantage of the high impedance is adding or removing speakers does not affect volume levels on existing speakers. Long speaker lines are possible with appropriate wire gauge because of the higher voltage. Using higher voltage amplifier outputs allow you to use the smaller wire gauge. Simple wall attenuators can be used to adjust volumes in each zone. So let's consider some wiring in commercial systems. A signal runs from one of your sources to the mixer amplifier system, which power the speaker chain. Then take your speaker wire from the amplifier to the volume control. Each speaker has a tap on the back, or sometimes in the front, and a little switch that lets you dial in the wattage it will use. So sometimes it's showing wattage, or sometimes it's showing ohms, or both. Wiring high impedance commercial system. So next we'll see the multi-zone setup. I'm sorry. No, this case we were using the single zone setup. Take the speaker wire from the output of the volume control and connect it to the input of the first speaker. Then they use the output of one of the speaker to connect to the next, and then repeat these steps for the rest of the speaker in this setup to create a chain. Next, we will look at the multi-zone setup, as this is much more involved system than the previous design. First, you will want to add a wattage of all the tap speakers in the chain, and that will give the total power needs for the system. So you can see the total amount is 40 watts for 2 speakers, and it's less than 50 watts of rated power output. you will want to the number of less than the rated power of the amplifier you select. We recommend choosing an amplifier with enough leftover power to give you some room to expand your system in the future. If you choose an amplifier that leaves headroom for the future expansion, you can easily keep connecting speakers this way to scale up the commercial audio system. This type of installation simplifies your connections, save a ton of wire over the traditional audio setup, and is designed to run all day, every day. Let's discuss the parallel connection in a 70-volt system. Starting off with some simple wire examples. We will first look at the 70-volt parallel wire example. Typical 70-volt design with the mono output and tap settings at 2 watts. 70-volt designs are connected in parallel. Scaling up the system up, and let's now look at much larger 70-volt system. Power needs should be always kept in mind when designing system. Ask yourself, what is power need for this project? In this example, 50 speakers are required. So total speaker wattage plus extra 20% for safety that we discussed before. We need to keep some buffer for the power amplifier wattage. In this proposed setup is the minimum of 120 watts amplifier is required. Here are more complex scenarios with the multi-zone system. Let's determine how the power handling for the volume controls for the speaker connected to it. Do that for each zone. Volume control will need to be higher for line loss. Next, we connect the other 2 volume controls to the amplifier. This could be done in 2 ways, depending on the distance of the volume controls to the amp. Again, keep in mind power consideration, how powerful amplifier do we need. Break down the diagram. So wattage going to different zones via different attenuators. Add up volume control wattage, 175. So 550 plus 25 plus 100. And speaker wattage is 93. So speaker zone 1 30, zone 2 3 watts, zone 3 60 watts, so 93 watts. So if the system is fixed, then 120 watts amplifier will suffice. However, if system can grow, then amplifier of 200 watts is good, as it covers the output wattage of 3 volume controls. So again, we have a spare wattage for volume controls, but we need an upgrade amplifier in order to supply all of them 175 watts. So now let's discuss 8-ohm wiring in parallel. So looking at 8-ohm parallel wiring, first off, ensure you calculate the total resistance to ensure the amount of speakers. Work with 8 4-ohms amplifier. Note that many amplifiers are not designed to impedance lower than 4 ohms. Impedance divided by quantity of speakers, this will equal overall impedance. So as you can see here, 2 8-ohm speakers will have 4 ohms, and another speaker line 8 plus 8 divided by 2, it will be 4 ohms. So total impedance will be 4 ohm. So let's discuss 8-ohm wiring in series. So of course, when you connect 2 speakers in series, will be 16 ohms. Again, first ensure to calculate the total resistance and to ensure the amount of speaker works with the 8 4-ohms amplifier. So if this 8 or 4 ohms amplifier and you connect 16 ohm speakers, the total power transferring to the speakers will be twice less because their impedance increases 2 times. So the amplifier cannot deliver this total amount to the speakers. For example, this amplifier has 100 watts at 8 ohms. At 16 ohms, it will be less than 50%. Also important about the twisted cable and how to use it. As an end note to our discussion of commercial audio system wiring, I want to take a moment to go over twisted cable and when to use it in the system. Twisted pair wiring, when required by devices, is designed to eliminate external interference common to the wire pairs. Since the pairs are twisted together, this external noise equally distributed onto the wires. The sending and receiving circuitry is expecting that this twisted pair are used as pair. If not properly connected as a pair, the noise cannot be rejected and could use equipment dysfunction. Also, please pay attention to the color coding of twisted pair cable, as if similar colors indicates the combined twisted wires. They are normally coded as solid color and the same solid color with their white. The typical example is a Cat5, Cat6 cable. Okay, if you have any questions, please let us know so we can answer. And yeah, I can take to the quiz now.
Yeah, so a bit of a more info intensive one this month. So if there are any questions, if you'd like to circle back, maybe touch a bit more on a specific part of this webinar, speak now. You can use a chat, you can use a Q&A. Let us know if there are any questions and we can address them. Then after that, we'll go over to our draw for this month. And from there, we'll all be on our merry way. We'll give it a couple minutes, let people type out their questions. And if there's nothing, then we can carry on. So I'll say we'll reconvene in about 2 minutes if there's nothing.
Yep.
Got one? No, that's. Where can we grab the PDF of the slideshow? It'd be great. Oh, so all of these will be every Dr. Sound Academy webinar gets recorded and uploaded to our YouTube, and that gets posted. Try to always aim for the afternoon after the webinar, if not the day after. So, in terms of the PPT itself, Dylan, I can reach out to you after the webinar to ship that your way via email.
Yeah.
And then our website has a bunch of this content on it, more segmented, easier, like minute reads over in Sound Talks or in our other support content on toacanada.com. And yeah, that's always another supplemental bit of a little tool that we try to give everyone, keep in their back pocket if they ever need it. We have one from Don Cochran, or Cochran, I'm sorry if I butchered your last name. So essentially a high impedance system. You size your speakers for the space first and work backwards from there to the size of the amp. Correct?
Yeah, basically it's correct. So you see what your space, what the size, what the requirements. You choose the speaker and you choose the how many of the speakers. We use the software for that. We can simulate what the speaker sound pressure level be. And after that we know how many speakers, what total wattage, you select the amplifier. Of course, we recommend using to use 80% maximum of the amplifier output for the PA system. For the professional, like a live music system, 8 ohms, we usually to give 50% margin for like the sound that like from the drums or that can have a room to actually play or replicate that sound on the speakers. Yeah, but basically, yeah, you're correct.
All right, so I think a couple people drop off right now. So if that's everything for questions, we'll move on to the draw. And if there is ever, I can say this while we go on to the next one, the next slide. If there are any, questions that don't get answered today, or if anything ever pops into your mind, always, like I said here, feel free to contact us here at TOA. We're happy to assist. Just future design considerations, questions that you have about existing TOA systems, or just workshopping things for the future, reach out, let us know, let us help. That's what we're here for. Without further ado, though, we will get on to the draw. So this month we're drawing off another pair of our F1000 This month it is our F1000 washproof speakers, getting prepared for the lovely weather that we're all having in the coming months. And so I will spin this here, get a bit of a drum roll going, and we can see who's walking away with a pair. We're looking at, I do hope I don't butcher your name twice, Don Cochran. I hope I'm saying that right, but you are the lucky winner for this month. Let's see, oh, yeah, someone's still here, there we go. So Don, I'll be reaching out to you shortly after this webinar, trying to get those speakers over to you. Congratulations, you had horseshoe somewhere, lucky rabbit's foot somewhere. But
Yeah, this nice speaker. You can place on a patio or something.
you can play Kristen for months to be, and it can be staying outside. But to everyone else who showed up and still here, thank you. Again, all of these are on our YouTube afterwards, but I'll look at sharing out the PPT itself for more educational material. Thank you, and we'll see you in 2025. Everyone have a nice holiday season, and take care.
Yeah.
Dr. Sound.